Good afternoon, kids. Here we go again. The topic for today is graphing absolute values. Okay, absolute values, guys, is pretty similar to quadratics because it has access to symmetry and it also has a vertex. So first, let's see what absolute value is. Absolute value, guys, is represented by these bars right here. So when we graph absolute values in the calculators, make sure we know we use the bars, and I'm going to show you how. By the way, all the instructions on how to use it in the calculator is right here. So remember, first of all, we're going to do this without the calculator, then we're going to do it with the calculator. But when I go over the instructions or the steps, use this information right here. Please read. So look, absolute values are represented by these bars with the X. And also, it's very important that you remember the absolute value means how many spaces from zero, okay? It doesn't matter if it's negative or if it's positive, because the other way to remember is distance, okay? And remember, guys, distance cannot be negative. So if I ask you to find the absolute value of positive 3, it's 3 because 3 is 3 units away from 0. If I ask you to find the absolute value of negative 3, it's positive 3 because from negative 3 to 0, you walk 3 units. Negative 3, you start at negative 3, negative 2, negative 1, 0. So you get 3 units. That's why we're talking about positive numbers, not negatives. So please, it's very important. Every time we talk about absolute value, we mean positive numbers. Unless if the negative sign is outside. That's a different story, okay? Because that will be the negative of the absolute value of a number. So remember, so to graph this, I know that the absolute value of negative 2 is positive 2. The absolute value of negative 1 is positive 1. The absolute value of 0 is 0. The absolute value of 1 is positive 1, not negative 1. A lot of kids get confused. The absolute value of positive 2 is 2. Some kids think because here they were negative and becomes positive, they think it's going to be the same thing here. If it's negative, if it's positive, it becomes negative. No. Always. The absolute value of a number is always positive. Let me write down here. Absolute value of any number is always positive, all right? Remember, we're talking about distance, all right? That's why you cannot have negative distance, impossible. All right, so now that I have my table here, I'm going to graph, okay? If you notice, this will be my vertex because you notice everything start repeating after here. So, like I say, it's similar to parabolas, right? So if the vertex is 0, 0, okay, when x is 1, okay, y is 1. When x is 2, y is 2. And that will go forever. So now what I'm going to do, I'm going to get my image. You can move to the left, match the other point, move to the left, and match the other point, and you can clearly see, okay, that the absolute value is going to go in two directions. But listen, this is what I told you in the beginning when we did parabolas, not to do lines, because it will look like an absolute value graph, not as parabola, all right? The absolute value, you actually have two lines that comes from negative infinity and goes to positive infinity. It hits a minimum, all right? Because this is a happy face. Remember, it's the same thing. This one is going to be, well, it should be, I'm sorry, my bad. It should be a V, a happy V, okay? A happy one, my bad. If that would be negative in the front, it will be sad V, okay? So that will be the principal function of a absolute value. So y equals the absolute value of x. Another thing I can tell you guys, look, the vertex of this is going to be always 0, 0. It's like when we did parabolas. Remember the parabolas why x y equals x squared, you know that the vertex is going to be 0, 0 no matter what. So the same thing here. The vertex is 0, 0. I'm going to show you also how to graph this without the tables, just using that, because for this absolute value, we can assume that it's a slope there. And if you notice here, the slope will be 1, because the slope here, the number in front of here automatically is 1. So if you think about it, because it's positive, when I start from the vertex, look, 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, and I just do the image after that. You see what I'm talking about when we get to the next ones, okay? So look, now, they telling me, all right, I'm telling you here how to graph absolute values in the calculator. So I'm going to show you how that looks, the main one, okay? So look, let's go to put it on calculator and then just eliminate that. Clean your memory, remember, second plus 712. Now, it's very important, guys, because the calculators are different. If I'm going to graph the principal of an absolute value, this is what I have to do, okay? Like, again, everything is right here. But I'm going to do it quickly because I remember. Y equals, to write the absolute value, is listed over here in the instructions. You're going to go to math, okay? This button, math, to the right until you get the number. And you see the first one is absolute value. Some of the calculators, when you do that, you're going to get it just exactly as you look there. Abs with a parenthesis. So you have to type X here. But my calculator is going to be different, because if I click 1, because that I'll get the bars. See? In some of your calculators, and some of your calculators get the bar too. So if you get the bar, just type X and make sure you X it out, okay? And graph. And there is the main function, the graph of the main function. Now we're going to do transformations, because it's exactly the same thing as parabolas. So if I keep reading my instructions, it says to put in the calculator, okay, all these ones right here, look, put in the calculator, complete table and graph each equation on the same axis as number 1. What it's saying to say is like, we're going to graph all these 3 in the same plane, so we can see the transformations, what's happening. And you see what I said before? This is the instruction. You're going to go to Y first, right? Math, move the arrow to number or tab, right? Press 1 and fill in parentheses with what is inside. What it means is this, guys, because some calculators, you're going to get Y equals, and you're going to get the word abs just like that. So you're going to type the letter X and you're going to close parentheses. If you notice, in my calculator, I got Y equals and I got the bars. I didn't get the word abs, but I know the bars means absolute value, okay? And I just tap the X. It's the same thing, all right? So, because we already saw transformations on parabolas, okay, I can use that too here. Look, pay attention, because you don't need the calculator to graph the absolute value now that you just recently did transformation on parabolas. Now, if you forget in the future, you can do it on the calculator, and I'm going to show you how, all right? So look, this is the main function, okay? Y equals the absolute value of X. What happens? I just put -3 outside the bars. So it's the same thing. This is reading as a vertex form. You don't realize that, but that's a vertex form. If I do that as a vector form, look what happened. That's H and that's K. Remember, when I write my vertex, the value of H changes. K doesn't change. So in this case, okay, guys, just for you to know, my vertex is going to be 0 because there's nothing in the bars, and -3 because that is K, and K never changes. All right, so look, before that, before we fit in on the table, look what's going to happen. So the only thing, if I ask you, what happens when I subtract 3 to the main function? You will say the graph, okay, moves down 1 unit. And it keeps the same shape, nothing happens. The shape or the size is going to change when we have a number here. So look how simple it is. I know that's the only thing that's going to happen with concern to this. But if you're not sure how to graph the rest, look, this one right here it should be the slope here. And the slope here is positive 1. Why am I telling you this? Because with the vertex and the slope, you can graph any absolute value function. So let me show you what I'm doing now, okay? So let's go, before I'm filling out the table, we can do that after too. I'm gonna show you how to do it in the calculator. But look, so if I go to my vertex, which is 0, 3, negative 3, so that means that my vertex now gonna be right here. Now, because I know this is a happy V, okay? That's a happy V. So the lines have to go up. So from here, from the vertex, I'm going to use my slope. Sorry, where's the slope? I'm going to use my slope, which is positive 1, okay? So from this point, I'm going to go 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, and I'll do the same thing to the other side. Now, you can go in reverse, or you can just do exactly what we did with the parabolas. Look, if I go in reverse, I will go 1 up, 1 to the left, 1 up, 1 to the left, 1 up, 1 to, because I'm going in reverse. Or you could say, okay, let me open one and just match the point on the other line. Open again and match the point on the other line. Open again. So you have two options. You can use, okay, guys, you can use the slope, or you can use, after you find the point from one side, you can just find the point of the other side by using the reflection, okay? By using also your axis of symmetry. So in this case, your axis of symmetry is x equals 0, still the same. So here I'm going to write y equals the absolute value of x minus 3. Okay? Now, if I want to find the number, okay, these values here, if I want to find the values of y, so what I'm going to do, I'm going to use my calculator. I'm going to go to y equal, turn it on, y equals, and what I'm going to do is, okay, on my second one, just for now, so I can see what's going on my second one, I'm just going to type this one, okay? So second to the right, I'm sorry, I'm not second, math, my bad, to the right, number 1, and I'm going to put x. I'm going to exit out. You have to exit out because the 3 is outside, minus 3. If you have parentheses, the other one, absolute, put the number, the x, close the parentheses, put the minus 3 outside. And if I go to my graph, you're going to look exactly what I just did now. Look, I can clearly see the parabola didn't open, did not close, remained the same shape, same size. It just like moved down 3 units. Okay? Now, to find the numbers, you're going to go and be careful. In this case, you have to use the second column, right? So you're going to go to second second graph, and you're going to concentrate on y2, because this one, these two are the coordinates of the main function. So this one is the second function. So if I know already that my vertex is 0, negative 3, so I'm going to go look for my vertex. And I'm going to concentrate on these two. So I don't see the x here. The x here, when x is 0, look, all right? Y is negative 3. So because that's my vertex, I have to find the other 2 points below, because, or you can just find until the numbers start repeating here. As you can see, they start repeating right here. And even though we don't ask for 7 points here, we only ask for 5, it's the same thing. If you put 7, it's not going to hurt. It's not going to hurt you. So when x is negative 1, what is the value of y? Negative 2. If when it's negative 2, it's negative 1. So this is negative 2, and that's negative 1. So here, we're going to start repeating again. All right? So that's the table. You know, I don't even have to graph it because I already graphed it. So if you know how to graph without the calculator, right? You don't have to show the table, you can do it like that. If you have to show the table, then you have to do it the other way. Now, look what's going to happen with the other one. The other one, just let's do what we did before. Let's find the vertex first. So this is H, and that's K. Now, if you notice here, in this one, I have H, but I don't have K. Therefore, K has to be 0. All right? So my vertex here is going to be negative 3, 0. Because remember, guys, right? H always changes. So I already have my vertex. So if I find my slope, I'm definitely gonna know how to graph that easily. So the slope here is also 1. And this one is another happy V, okay? So to graph that, this is what I'm gonna do. Without looking at the table, I don't need the table. So without looking at the table, I'm gonna go to my vertex, which is now, oh, by the way, also, if I ask you guys, what's gonna happen when you add 3 inside the bars to an absolute value function? So you can tell that the graph is gonna move to the left 3 sides. Then I ask you that, I'm just telling you because we just did transformations on parabola and it's the same method. So you will write the parabola, okay, moves 3 units to the left. All right, so let me graph it now. So if I graph it, I'm gonna go to my vertex, which is 3, negative 3, 0. So the vertex here is gonna be right here. And if I use my slope, which is 1, because it's happy face, remember it's happy V, so I'm gonna go from here, 1 up, 1 over, 1 up, 1 over, 1 up, and 1 over, and it's gonna go on forever. Now to find the other points, you have two options. You can go in reverse with the slope, or you can just find the image. So let's say if I wanna find the image, all right? What it means is, I open to the left one, and I just wanna combine it to my other point right here. Again, I open up and I combine it with the other one right here. Open one more. If you notice now, these points are gonna be in the same line as the other function. I'm gonna do my graph then. All right. Let me do my graph. All right. And this is my second function, okay, or my third. Y equals the absolute value of x. Is it plus 3? Plus 3. So compared to the main function, the first one just moved down 3 units. The other one moved to the left 3 units. And now we're going to do a third one. Oh, now to find the same thing, to find the values of this, of the table, right? You're going to do the same thing what I did before here. All right, let's go to y equals. Let's eliminate the second one. And let's type the other one. So it's going to be, there's a number on the front. So it's going to be math to the right, number 1. And I'm going to type x plus 3. Exit out. If I graph it. Now, this is the main one. And this is the other one that I just graphed now. All right. So you can clearly see that from the main function, it just moved to the left. Okay. 3 units. Now to find the values of y, I'm going to go to second graph. And because I know my vertex is negative 3, 0, I have to make sure this is in the middle of the table. So my negative 3 is right here, okay? And the 0 is there. So I'm going to go up a little more until I get the perfect table. If you notice here, it's like a parabola. The numbers start repeating. In my vertex, negative 3, 0. So what happened with negative 4? Positive 1, with negative 5 is positive 2. So that means that the numbers are positive 1 here, positive 2 here, 1 here, and 2 here, all right? So, I already graphed it, so I don't have to graph it, but let's say if you were to find these points first, then you would have to graph it after. So I'm graphing first and finding my table after. You can find the table before and do it after. But then again, my point is that since you already graph parabolas and you're using the same property for transformation, it will make it easy for you. So look, now we go with the next one. If you know the next one, the vertex is going to be 0, 0. Why? Because h supposed to be inside the bars and there's nothing, and k is supposed to be here and there's nothing, so that means it's 0. So the only thing I know is going to happen is this. So I know the vertex is 0, 0. So if you look here, guys, you slope here, right? Is negative 3 over 1. So here the numbers if you don't know the slope, you're better off finding the table first. But if I'm going to ask you what happened with this, what happened to the main function when I multiply it by -3, it's going to happen two things. Because it's negative, it's going to be a ZV, okay? It's going to be a ZV. And because it's bigger than 1, the 3 is bigger than 1, it's gonna get narrower, or it's gonna shrink. So if I ask you to describe what's happening, only if I ask you, you will write the the graph will flip over the x-axis, and it shrinks and shrinks. And it shrinks, or you can say it gets narrow. All right, now, so let's graph without looking for the table. We can find the table after. So if I'm gonna graph that, I'm going to go to my vertex, which is 0, 0. Okay. Because it's 0, 0, and I know it's negative slope, from this point, I'm gonna go 3 down and 1 over, okay? 1, 2, 3 down, 1 over, 1, 2, 3 down, 1 over, 1, 2, 3 down, 1 over, and I can use my slope in reverse, or I can just find my image. Let's use the slope. 1, 2, 3, 1 to the left, 1, 2, 3, 1 to the left, 1, 2, 3, 1 to the left, and I have there my points, and I can clearly see that the graph got narrower. So y equals -3, the absolute value of x. And you can just pick the values of y from the graph, okay? What happens when it's +1? So when it's +1, you see, when it's +1, y is -3. So -3 here, -3 here. When it's +2, it's -6. So it's -6 here, -6 here. So you can get the point from the table too. All right? So now let's just move on. And as you can see, we have 4 different functions. We have the main function, and we have 3 different ones, which causes the main function to turn into another function with a different type of graph. Okay? So let's go for this one now. Here, all right, they're asking me, write the corresponding absolute value function that describe each of the graphs shown below. Now, I'll give you the graph, and you have to give me the equation. Remember, it's not too difficult. Just find the vertex and find the the slope, and you'll be happy. You'll be done. All right? So look, the vertex here is right here. The vertex is +2, 2. Remember, that's h, that's k. All right? Now, I can clearly see that the graph, I can clearly see that the graph got narrower, okay? It shrank, because usually the absolute value is wider, right? So how am I going to know if it shrink or not? Finding the slope. So you have to find 2 things here. Find vertex. Second, find slope. Okay, so the vertex here, I told you that is 2, 2. That's h, that's k. And the slope here, look, it's a happy face. You can tell it's a happy one. So because it's a happy V, from the vertex, just find the slope. You can see that go to up, 1 over, to up, 1 over, to up, 1 over, to up, 1 over. So the slope here is 2. So I'm ready to write my equation. Y equals the slope first, 2, the absolute value of x. Now, because h is +2, I'm sorry, let me see if I can, it's better because I don't wanna mix. Okay, so you can see here, guys, that because H is positive 2, that must be negative here, okay, inside the parentheses. And because this one is positive 2k, that will remain positive. So that should be your equation, okay? That should be your answer for that. I just don't want to ruin my paper here. All right, okay, much better. So you can clearly see that in the vertex, that's H and that's K, the H always changes and the slope is 2. Now, take a look at the other one. The other one, same thing. Now, the other one is a Z phase, okay? Because the Z phase is going to be a ZV, all right? And you can also see that it's getting open, it's getting like wider. So first of all, let's find the vertex. So the vertex here is -1, +2. And let's find the slope. The slope here is from the vertex, you know, because it's going down because the Z phase has to be negative, okay? You go down 1/2, 1/2, 1/2, all right? So the slope here is -1/2. You don't care about the other side because the other side is just the image, right? You have to concentrate if it's a happy phase, goes up, your slope is a positive slope, and if it's negative, if it goes down, it's negative slope. So I'm ready to write my equation. So y equals -1/2 the absolute value of x. Now, because h, remember that's h, and that's k, because h is negative becomes positive, and k stays the same. All right? So that's how you write an equation, okay? And if you want to make sure it looks like that, you can put that on the calculator, and you should get that graph. Okay? So now let's do the ones on the back. And I think you have two like that on the homework that you have to use. I don't know if you have to graph it or identify it. Okay, this one. To do this one, guys, now we have a system. Remember we did parabolas and lines? They had two solutions, one solution, no solution. This is the same thing. Oh, that's the one on the bottom. Here, I still didn't get to that part yet. I was going too fast. So they're asking me here to graph, identify the vertex of the function and the axis of symmetry. It's a lot easier. H, K. So that means that my vertex is going to be right here already, because I got it right here. It's going to be +2, 0. All right? And the axis of symmetry is always the value of x from the vertex. So the axis of symmetry is going to be x equals 2. Just like the parabolas, same thing. Now, to graph this, I need the vertex and I need the slope. And look here, my slope here is -1. That means -1/1. So that's going to be a Z, okay? It's a ZV. So how am I going to graph this? Let's start with the vertex. The vertex is 2, 0, right? So it should be here. And I'm going to use my slope. 1 down, 1 over, 1 down, 1 over, 1 down, 1 over. And I just make the reflection. 1 down, 1 left, 1 down, 1 left, 1 down, 1 left. And I should have my graph right there. Simple. So you see, everything is related to each other. You learn lines first because now you're using lines. Okay, here. So there's your graph, you have the vertex, you have the axis symmetry. Next one here. Look, if I were to ask you, describe what's going to happen to the main function when I convert it to this function, you will say, because the 2 is bigger than 1, it will get narrow or it will shrink. And the vertex will move 3 units to the right and 4 units up. But we're not describing. But just remember what we did with parabolas. It's exactly the same thing. Now, if I want to graph this, I need to find my vertex. And you know this h, that's k. So the vertex here is going to be positive 3, comma 4. All right? So my axis of symmetry is the value of x from the vertex. So my axis of symmetry x equals 3. Now let's graph it. To graph, I need the vertex, which I have, which is 3, 4. So that means 1, 2, 3, 1, 2, 3, 4 is right here. I just need the slope. And the slope here is positive 2. That is my slope. So from that point, I'm going to go 2 up, 1 over, 2 up, 1 over, 2 up, 1 over, and I can go in reverse. 2 up, 1 left, 2 up, 1 left, 2 up, 1 left. Hopefully, if I ask you to graph, I like to see V's, okay, guys? Not all the letter, only V's, because with the parabola, some of you made so weird graph that I was going like crazy. Like, what are you guys doing? I mean, all right? And you can clearly see that, like I told you before, from the main function that will go here from 0, 0, it moved 3 units to the right and up 4, and it shrink. That's easy. And the last one is a system. This is what I'm talking about. The system here, guys, is a line and an absolute value. Remember we used to do lines and parabolas, right? Now it's lines and absolute values. So let me just get my paper together. All right. All right, so look. This is a line. That's a horizontal line. And that's my absolute value, all right? So the horizontal line means it crosses the y-axis. And what is the value of y there? -6. So if I go to my graph, and I go to -6, should be on the bottom. 1, 2, 3, 4, 5, 6. So that should be my line for the graph for the line. And now label it y equals -6. And I'm going to graph my absolute value. Look what's going to happen here with my absolute value. If I compare this to the main function, it's going to flip because it's negative. It's going to get narrower because the 2 is greater than 1. Move to the right 3 units and up 6. But they're not asking me to describe. But that's what you have to do if they ask you to do that. Now, to graph this, guys, okay? To graph this, I need my vertex, which is h and k. And they're asking me here, identify the vertex of that function. So the vertex of this is -3, 6. Where the axis of symmetry? The axis of symmetry is the value of x from the vertex. Oh my God. I don't know if you were able to see, but my battery is running low, so I think I can finish because I'm almost done. All right, so what I'm saying is then I'm going to do, so I'm ready to graph. If I start off my 3, -6, which is going to be here, -3, 1, 2, 3, and +6. I'm sorry, my bad, it's +3. 1, 2, 3, 1, 2, 3, 4, 5, 6. It should start there. Then what's my slope? My slope here is -2, 1. So from here, I'm going to go 2 down, 1 over, 2 down, 1 over, 2 down, 1 over, 2 down, 1 over, and I have to continue because I'm looking for the intersection point, and they're going to touch right there. I can also go backwards, 2 down, 1 left, 2 down, 1 left, 2 down, 1 left. Okay, and that would be my other. Okay. That will be my other intersection point of the system. Okay, let's see. So it should go a little over, to go over to infinity. So my solutions point is right here. So my first one is going to be -2, -6, and 9, 6. So this is the 2 points when the line and the absolute value graph intersect. All right. So that concludes the lesson for today, and the homework is going to be for Friday. So you have tomorrow, Thursday, and Friday. I think it's not a hard lesson. So since you already have experience with the parabola, so I think it should be fine. Stay well, and I'll see you next time.